Now, we're going to take up one more problem. Problem number 24. A brass bar having a cross-sectional area of 300 mm square is subjected to axial forces as shown in the figure. Find the total elongation of the bar. Take E equals 84 GPa. So this has been asked several times in March 2001, June, July 2013, and January 2016. So here you can see there are three cross-sections, cross-sectional uniform cross-sectional area of 300 mm square, but you have three segments. So in the first segment on the left hand side it will going to be 50 kilonewton, and in the second it will going to be on the other end it will be 80 kilonewton towards the right side, and in the second segment again you can have in the end of the second segment you have 20 kilonewton towards the left side, and again in the third segment you have 10 kilonewton towards the left side, and you have the first segment has 500 mm length, the second segment has 1400, and the third segment has got 1000 mm. Now first we need to find out the solution. So whether the body is in equilibrium condition, which we want to test. So what is the condition? For the equilibrium of the bar, load acting towards the right side or the load acting towards the right side is equal to the load acting towards the left side. So which is the load acting towards the left side? You have 50 plus 10. So you have 50 plus 10 on the one side. Load acting towards the right side is equal to load acting towards the left side. So load acting towards the right side. So here we have 50. Then you have plus 20 plus 10. So what will be the total value? 50 plus 20 plus 10, it becomes 70 plus 10, 80. And load acting towards the right side will be equal to 80 kilonewton. Since 80 kilonewton is equal to 80 kilonewton, and hence it is right. So if you want to have to this value, a load acting towards the right side, if you consider 80 kilonewton, which will be equal to the load acting towards the left side, 50 plus 20 plus 10. So 80 is equal to 80 kilonewton. Since the LHS is equal to RHS, hence the bar is in equilibrium condition. Now we will try to write the free body diagram of the different segments. So what is the first segment if he says? So in the first segment, if you see here, you have a 50 kilonewton acting towards the left side on one side. Then which are all the forces acting towards the right side? So 80 kilonewton, 20 kilonewton and 10 kilonewton. So which is acting on to the second side of the, other end of the side of the segment. So you have a 500 mm length having uniform cross-sectional area of 300 mm square. Now we need to analyze the free body diagram. So to do that, so here the load acting towards the left side is considered to be positive and the load acting towards the left side is negative. So 50 kilonewton will be equal to the load acting towards the right side is 80, which is positive 80. Then again you have minus 20 and again you have minus 10. So 80 minus 20 minus 10 according to the sign convention. So 80 minus 30 will be equal to 50. So since it is a positive value, see the positive value is in this direction. Therefore, on this side also you have is 50 kilonewton acting towards the right side. Now when you go to the second segment, so when you come to the second segment here, you have 50 is acting towards the left side, again 80 acting towards the right side on the left hand side of the second segment, and 20 kilonewton is acting towards the left side, and also the 10 kilonewton is acting towards the left side, so which is again on the right hand side of the segment. So to check this, you have minus 50 which is acting towards the left side, and also plus 80 is acting towards the right side. So that means minus 50 plus 80 is equal to 30. So since it is 30 is positive, according to the sign convention, the 30 should act towards the right side. So you take 30 towards the act to the right side. Then the force which is acting, which are all the forces which is acting onto the on the right end, how much, which are the forces? One is 20 kilonewton and the other one is 10 kilonewton, which is acting towards both are acting towards the left side. So here, if you see minus 20 and minus 10, so according to the sign convention, acting towards the left side is minus. So minus 20 minus 10, it will be equal to minus 30. Since it is minus 30, it is acting towards the left side. So since on the other end, 30 kilonewton is acting towards the right side, and in the 30 kilonewton on the other end, 30 kilonewton is acting towards the left side. So both are in equilibrium condition, and also we can see that it is a compressive load. We have an area of cross section of the segment as 300 mm square and the length of the segment is 1400. So now we go for the third segment. In the third segment, which are all the forces which is acting? 50 kilo on the left hand side of the third segment, 50 kilonewton is acting towards the left side and 80 kilonewton is acting towards the right side and 20 kilonewton is acting towards the left side. So only the force which is acting at the other end in the last segment is minus, that is the force acting towards the left side is 10 kilonewton. So according to the sign convention, so what we are trying to do here, according to the sign convention, the load acting towards the right side is considered to be positive and the load is acting towards the left side is considered to be negative. So according to this, the load is acting towards the right. So you have minus load acting towards the left side is negative, minus 50 plus 80 minus 20. So minus 50 plus 80 minus 20, which is going to be 10 kilonewton. Since it is 10 kilonewton, which is acting towards the right side, so 10 kilonewton is acting towards the right side. Similarly, you want the only 10 kilonewton is acting towards the left side in the other end of the sub bar. So it is going to be 10 kilonewton since it is negative according to the sign convention. So you will going to get minus 10. So since it is negative, so here if you see the direction of force which is acting negative is towards the left side. So according to that only, here since it is minus 10, so it is acting towards the left side. So you have the acting towards the left side will going to be 10 kilonewton. Since on the other end also it is acting towards the right side. So both the forces are acting opposite to each other and hence it is going to be the compressive force. So next we need to find out what are all the total elongation of the segment 1. If you are considering the total force acting on the first segment, which will be 50 kilonewton. So here we have the elongation of the segment 1. Delta L1 will be equal to, what is P1? P1 is nothing but 50 kilonewton. According to this convention, here 50 kilonewton is acting. So here it is a tensile load. So 50 into 10 to the power of 3. What is L1? Length of the segment, which is 500, divided by A, which is again it is 300, because uniform cross-sectional bar, into E. What is E? Young's modulus is 84 GPa. So it will be equal to 84 into 10 to the power of 3. So here once you do that, so here delta L1 will be equal to, on simplification, you will going to get it as 0.9921 mm. So now we go for the second segment. So since it is a compressive force, again the contraction of the segment 2, which is delta L2 is equal to P2 into L2 by A into E. So what is the second segment load? The second segment load is again, which is on the compressive, it is 30 into 10 to the power of 3, 30 into 10 to the P2 into L2 by A into E, 30 into 10 to the power of 3 into L is the length of the segment is 1400. According to this, here you have 1400 mm, that is the length, by A is 300 mm, which is uniform bar of uniform cross section, into 84 GPa, Young's modulus 84 into 10 to the power of 3. So on simplification, delta L2 will be equal to 1.66667 mm. Similarly, in the third force, you have again you are having the compressive force. Naturally, it is contraction of the segment 3. Delta L3 will be equal to P3 into L3 by A into E. Why we are considering only A? Because it is a uniform cross section of A is 300 mm square. So P3 is 10 into 10 to the power of 3. According to this equation, 10 kilonewton compressive. So 10 into 10 to the power of 3, because here you are converting the kilonewton into Newton. Into L3. What is L3? The length of the member is 1000 mm into 1000 divided by area. It is 300 into Young's modulus is 84 into 10 to the power of 3. Therefore, delta L3 will be equal to 0.3968. So what will going to be the total change in the length? The total change in the length of the bar, delta L will be equal to delta L1 plus delta L2 plus delta L3. So delta L1 is positive 0.9921 because it is a tensile, and 0.9921 which is again tensile, it is positive. Delta L1 is positive. Since delta L2 is the contraction of the segment, it will be minus. So minus 1.667. minus again because in the delta L3 also you can see there is a compressive force. So naturally delta L3 will be equal to minus 0.3968 mm. So on simplification, you will, since the negative value sign is more, minus 1.074 mm. Therefore, total change in the length of the bar delta L will be equal to 1.0714 mm. Since it is negative, so it will be compression or contraction. So this is how you will be able to solve this particular problem. Thank you.